Here's a video of an example I saw at the TI conference where someone walked through the geometric creation of a parabola from its definition, and then from there deriving the algebraic formula for a parabola in vertex form. So I thought it was pretty cool the way they did it. It's a little bit lengthy, a lot of steps, but very intuitive. And I wanted to do this video, and I've got a handout just so I could remember exactly all the steps to bring it back to life sometime. So I start out with a graph page, and I'm going to tell them that, the definition is a parabola is all points equidistant from a focus and then to a line called the directrix. So you could draw that out and show them geometrically what that is, but let's try to construct that. So let's start with a point. So we're going to have a point that we call the focus. I'm aiming for that to be 2, 5, just so that we all are doing the same thing. So I'll create a point here, and I'm going to, while I've got that point, I'm just going to name that point F. And now let's just figure out the coordinates of that point. So if I come over here and find the coordinates of this point, it looks like this point is 1.5, 4.97. Didn't get quite as close as I wanted to 2, 5. So I'm just going to change this point to the point 2, 5. So now I've got the point 2, 5. Next, I need a directrix. We're going to use a horizontal line at f of x equal 3. So I'll graph that as a function. But what I really need from a geometric standpoint is this is the difference in the calculator, the nuance of graphing a function versus a geometric line. I need a line from the geometry functions of the calculator right on top of that. So what I'm going to do is just say menu, points and lines. Let's draw a line, and I just select anywhere on that red. It needs to be on this point, and it needs to be on this point. And so now I've got my geometric line on the same point there. So you've got your directrix and you've got your line at y equal 3. Now what I need is from somewhere from this point F, I need to find, make a line segment that goes somewhere to a point on this directrix. Okay, so I will just create a line segment. So menu, points and line segment. Select point F, and it then needs to be on the line that I just drew. And I'm going to label that point Q. So I've got line segment FQ. So F is the focus, Q is just a point on the directrix. Now what we need now is I've got the parabola. You see the parabola is going to be doing something like a U shape. So I've got to figure out how is that constructed. So what I really need here, I need to do a perpendicular bisector to this line segment FQ. So menu, construction, perpendicular bisector, select this line segment. And there we go. So now we have a perpendicular bisector for the line segment FQ. And now, according to our definition, I'm going to have to go perpendicular straight up from Q to that bisector and then back down to F. That's going to be a point on the parabola. So I need a perpendicular line to the line y equal 3 at point Q. So what I'm going to do now is construct a perpendicular line. Select the line segment, this line segment at this point. And there we have our perpendicular line. Now what we see is I'm interested in that intersection point that I don't quite see. So menu, points and lines, intersection points, and I select the perpendicular bisector, perpendicular line, and now I've got my intersection point that you see right here. I'm going to go ahead and label that. So I'm going to label that point. I'm just going to call that point Z. So what happens is, if I go from Q to Z, that's a distance. That distance should equal Z to F. That's the definition of a parabola. So what I'll need now is a line segment. So let's create a line segment that goes from F to Z. Okay. And now you see that I've constructed the triangle. Now you can get into all kind of conversations. Okay. You know that you created 2 right triangles. You know these triangles are congruent. So you can talk about side, angle, side. You can really talk about side, 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 because of the definition of the parabola. So several conversations that can be had there about the triangles that we've just constructed. Now what you can see is what we're really after is we're going to be moving this point, and that's going to trace my parabola. Okay, so by moving, Q on a straight line, I've got a triangle that rotates. So moving on a straight line with a rotating triangle, and I get this curved parabola. So I want to get a little bit more specific about this. So I'm going to figure out, so what are the coordinates at point Z? So let's just do a couple of things. We'll go to Menu, Actions, and let's look at coordinates. And so at point Z, what are the coordinates? And sorry. So now as I rotate, I'm going to see those coordinates as I go along. Let me see if I can move that a little bit higher. So now I'll see the coordinates. So you see the coordinates as I rotate on line Q on the line there. Now the other thing that I'm going to need is I want to draw this out so I can sort of visualize when point Z moves. It looks like it's doing a curve, but we create something called a locus to do that. So if I go to Menu and go to Constructions, create a locus, I'm going to select point Z, and then I'm going to select point Q. And now what you see is as I move Q, you see that it traces, you see the locus of that. And so now I actually do start to see that parabola. Move things down a little bit so you can see it better. Okay? So again, very nice to see the visual for that. Now what we need to do, we want to say, okay, this all looks fine, but what I'd like to do, I'd like to capture the data on that parabola. So let's just figure out what those points are and just get some more information about it. So what I really want, is as I move along here and those points change, I want to capture those in a spreadsheet and do some analysis on that. So in order to do that, let me move this a little bit so I can get to those points. What I need to do is set up a variable. So set up a variable so that I can store the XY coordinates. So let's set the X coordinate here. And then if I go to Control var, that's going to store. So I'm going to store this in my variable called X. And you see it becomes bold. I'll select the Y coordinate. Same thing, Control variable, store that in a variable called Y. So now I have variables that are created to hold that data. So let's create a list and spreadsheet. So if I go create a list and spreadsheet, I'm going to have X value, and I'm going to have Y value. And then right here, I'm going to say, okay, this is menu, this is a data capture, and it is automatically captured from variable X. Okay, so now you see that should correspond to 6.47. That is my current X value on the parabola. And then the Y value here, same thing. Menu, data capture, automatic. Let's capture that from the variable Y. 9.01, that should correspond to where I currently see the value. So now I've got this list and spreadsheet set up to capture data from this geometric curve. So if I were to move it around, I just moved it just a little, now you see data capture. I have different points that have been captured on the parabola. So now the point would be to move as much as you can to collect data, okay? So I can move down, I could, make this point go even further. So I'm capturing data all along this curve, and I'm filling up the spreadsheet with different data points. Now let's look at this as a scatter plot. So let's look at, now we've gone from the geometric definition, let's start from the raw data that we have. So let's create a new graph, and then for the input, instead of inputting a function, so the graph type, this is going to be a scatter plot. And so my X points, they're going to come from the spreadsheet, X value. And my Y values are going to come from the spreadsheet, which we named Y value. And so this should look like a parabola, okay? These are all the data points that we now see plotted from our original, or from the capture when we did the geometric. So again, we started out geometric definition. We constructed it geometrically. We gathered data points, put those in a spreadsheet. We plotted those on a scatter plot. Now let's go back here and say, let's do the graph type as a function. Now, the first parabola you ever learn when you start to walk is x squared. So what does x squared look like? Well, so it tells me that my data is not exactly x squared, okay? So it's different than that. So can I figure out, just by sort of a trial method here, can I move this up and say, well, what would it be? That's not quite it, so let's see if I can move it some more. Let me move this label. See how close I can get. Okay, that looks pretty good. I need to widen this parabola a little bit, maybe a little bit more. And this will be tough to do with any real degree of accuracy on the calculator. So that looks pretty close, okay. So now you look, so I'm getting an estimate here. 0.26 x minus 2.07 plus 39. So that tells me that that looks similar, but it's not really exact. If I look over here, this one looks to be off a little on the right. Can't quite get a good match. Let's try that. Maybe that's a little bit better. So there you go. So I come up with a reasonable guess from my data. Now, we like things to be right, nice numbers in most of the problems you see. So maybe I was aiming for this to be x minus 2 squared plus 4. So that's a possibility. The way we can figure that out now is let's just add another sheet, which is a calculator page, and let's just do regression straight from the data points. So statistics, stat calculations, quadratic regression. So we had x value and y value, and there we go. So that tells me that it looks like 0.25 x squared minus x plus 5. That's telling me that that's the equation of the parabola that we just had. So now I've got two ways of getting that equation. One was I did it graphically, trying to estimate, by moving that parabola. The other thing, I did a quadratic regression. And I came up with, if I go to some of the instructions that I have here, these two possibilities. So I think from my graph that perhaps this is what the equation is, and this is what came back from the quadratic regression. So are these the same? Then you could walk through an exercise where you show that these are indeed the same equations. Okay. So that's pretty much it, but then there's several things you can do then to tie the lesson together. You could come in and say, okay, well now let's derive this from the geometry itself. We know that what's the distance from P to Q? Well, that's just going to be whatever the y value is, y minus 3, because I'm translated vertically up from that line. So I could say, let's use the distance formula, and I'm going to come up with the same parabola equation just by going back to that geometry. And then from there, depending on the level of your class, you can take it further. You can generalize. How would I, in general, find the equation of a parabola that looked like this? So we can start out the easy one, one that's on one of the axes or at the origin. So I can say, okay, how can I use that distance formula to get the value or the equation for this parabola? And then probably from an honors level standpoint, you could generalize and say, okay, if it's not at the origin, how can I use the distance formula to come up with that equation? So anyway, there's a lot of stuff there, a lot in the information. So anyway, thanks for watching, but I thought this was a pretty cool way to take concepts, and we've talked about integrating geometry and algebra, a good way to tie these things together. Thanks.